Swayam Prabha. Digital India. Educated India.
So, hello everyone. So, we will continue with the topic yarns for protective textiles. So, we have discussed different types of yarns, staple yarn, like coarse sheath yarn, composite yarn. Okay. Now, we will discuss the filament yarn. So, if we see the filament yarns are two types, monofilament and multifilament yarn. So, it is widely used for many technical applications including protective textiles. These are made from continuous strand fiber of indefinite length. So, there is no discontinuity. So, that actually adds to the strength of the yarn or uniform characteristics. So, long unbroken fibers are there. So, they are generally smooth, in lustrous and uniform, but different types of other cross section or other textured structure one can produce. Now, the spinning process, there are different types of spinning process, melt spinning, wet spinning, gel spinning. So, here in the filament spinning, the basic equipment is one spinneret is required, okay, through which the polymer solution may be in molten form or maybe in a solution form. So, that passes through and forms the continuous filament, which is then drawn by the gaudet roller and then take up spool, and in between we can apply the spin finish, and there are different processes are there. So, the different types of polymers can be spun, like polyester, nylon, rayon, okay, that polymers are melted and the rayon which is actually dissolved in a viscous solution. So, the polymers either are melted, the polyester, nylon, they are melted or they are dissolved to form viscous solution like rayon and all this. Polymer solution or melt is then forced through the spinneret. So, thermoplastic fibers like polyester, nylon, they are actually melted in the from the chips, and then molten polymers are forced through the spinneret, and on the other hand the viscous fiber, their viscous solution is formed and they are actually forced through the spinneret. Now, shape of the spinneret holes you can change, typically it is a circular, but different types of shapes can be produced. So, they are then solidified, melt spinning, they are solidified by quenching operation, that is a this is during the cooling process, cool air is there. So, that is a cooling process in melt spinning, and the in case of the dry spinning, the solvents are evaporated. Solvents are after the spinning through the spinneret, they are evaporated by processing through the passing through the hot air, okay. Solvents and we can recover the solvent. Solvent recovery plant as one can use. So, that the vapor from vapor solvents are recovered and the fiber portion are taken, that is a dry spinning, and in the coagulation bath in say like viscous or a. So, there is a coagulation bath, the after spinning forcing through the spinneret, the filaments are dipped into the coagulation bath, which is called wet spinning, and that the coagulation, after coagulation we get solidified fiber. The filaments are stressed to align molecules, increasing strength and orientation. So, after that this filaments are stressed in the Goddard roller. Depending on the stretch, the molecular orientation changes, and for highly aligned molecules the strength become very high. The filaments may be slightly twisted. Basically, if we do not twist the filament after spinning, then there may be the filaments may be disentangled, it fraying may be there. So, that may create the broken filament, individual filament. So, to form a group, so we sometimes apply very less low amount of twist. The continuous filaments are wound on a bobbin. There is a take up spool is there, ready for use in weaving or knitting. So, this is the continuous filament manufacturing process. Now, let us see the characteristics of filament here, made of long unbroken fibers. So, staple fibers, the main problem is that the strength is actually obtained through the twisting. By twisting we get the fiber to fiber friction, generally shiner and more uniform appearance. So, because these fibers are parallel and they are uniform in nature, because these filaments are produced through the spinneret, and spinneret hole is if it is uniform, then that means there is no chance of or least chance of getting non-uniformity in yarn cross section, filament cross section, because they are coming from a specific hole. High strength of synthetic filaments due to molecular orientation. So, due to the molecular at high speed when it is spun, and after stretching the molecular orientation will be is high. So, it creates high strength. So, there is no protruding fiber. So, unlike staple yarn, there are protruding fiber. So, here there is no protruding fiber, it gives the cleaner structure and it becomes lustrous, and it is a strong abrasion resistant. Peeling is effectively peeling is not there. So, there is due to they are free from short fibers, and low for microdenier filament, there after breakage they may form to some extent peels, but peeling in case of multifilament yarn it is not commonly visible, feels smooth, but less breathable than staple, that is okay. So, less breathable because its pores are not there. where through pores the fibers like the water molecule get so due to the pores present in the inside the structure of staple yarn, the water vapor molecule gets diffused through the yarn structure very easily, but in case of filament yarn, so this is breathability is less. Now, what are the advantages here? High strength. So, continuous fibers provide better tensile strength. This is very important. So, we for any high strength application we should normally try for the for filament yarn, smooth surface, produce lustrous shiny fabric, okay, with even texture, no protruding fibers. So, gives clean appearance. Durability is high because of resistant to abrasion and wear, low peeling tendency, dimensional stability of the fabric made from filament yarn retains it's good, it retains shape well because it does not get swelled. For staple fiber yarn, due to the pores, when water penetrates inside the pore, there is a chance of swelling, but here there is no such pores available. So, swelling is not there. Now, the limitation, if you see, slippery surface, low bulk and warmth, because in staple fiber yarn, due to the presence of the pores, the warmth is high because of the higher thermal resistance of the steel air. Its poor absorbency, because air pocket is not there where air water can penetrate. So, that is why it has poor absorbency. So, where we need absorbency characteristic, there the filament yarns we normally do not use. Static built up, particularly it depends on the type of polymer which is used. So, for synthetic polymer like polyester, so static built up chances are there. Low covering power, because of the for same yarn linear density, the diameter of filament yarn will be low. So, covering power for same mass per unit area, the filament yarn will form will actually result low cover factor, less natural look because it is a softness and natural feel. So, this is actually this will give a synthetic look like cotton fabric. If we see it is a natural look because of the some unevenness, some hairs, and it is a higher cost because this is not always true, and for some fabric, some yarn, it may be at the higher cost because that for a specialty filament, it reduces breathability, as we have discussed that the breathability is not there because of the absence of pores in the yarn. Peeling when textured. So, if we try to texture it, that in that case the peeling may take place. Applications of filament yarn in apparel, sportswear and active wear. Sportswear widely it is used. So, sportswear main advantage of this filament yarn is that there the high active sportswear, the staple yarn is not recommended. The basic reason is that in the staple yarn, let us see for the polyester. Polyester in the staple yarn we need higher strength and also the capillary. Capillary, if we draw the capillary, one ideal capillary, this type of capillary will be there in staple yarn. So, it is a discontinuous capillary and also it follows a helical path. In case of sports, in case of filament, the capillary will be straight or almost straight, because their filaments are along the aligned along the yarn axis. So, here for through the discontinuous pores, capillary channel, the flow rate of flow of the fluid will be very, very slow. And that is why in high active sportswear where the lots of sweatings are there. So, that wicking characteristics will be very poor in case of staple yarn. But on the other hand, if we use the filament yarn, that will give us the very high wicking rate. And also in sportswear we do not use normally the circular cross section, we use different trilobal or hexagonal, different pentagonal, different types of structure we use, because here the shape factor is high and the rate of wicking will be high. So, for sportswear we use filament yarn. Any high active sportswear we prefer, we do not use normally staple yarn. In home textile we use, industrial uses there, fishing and outdoor gear we use this filament yarn, because in fishing or outdoor gear as the this filament yarn does not absorb moisture. Okay, it does. So, that is and that is why in fishing and outdoor gear, when it is come into contact with the water, it does not actually take water within its structure, but for staple yarn the water penetrates inside the pores. So, that will makes the yarn much more heavier after absorption. In medical textiles, this is the area it is widely used. Technical textiles and protective textiles we use. Luxury textiles, sewing thread sometimes we use, but in sewing thread were very special type of applications are there, and we coarse spun filament yarn we use. And twisted yarn, as I have already mentioned, the twisted yarn depending on the fiber alignment during twisting, it is either Z direction which forms the Z pattern, and here it is S pattern. Two types of twists are there, and twist yarn either in the spinning we can twist, or different filament together we can twist. Okay. Wide range of applications are there. So, the process involves twisting fibers to hold them together. So, it may be a staple fiber or maybe filaments. So, fibers are twisted in the same direction as central part of the letter S or Z. So, if we see the characteristics, the twisted fibers actually the during twisting the fibers are brought together, which increases the strength by increasing the cohesion. Twisted yarns have some stretch due to spiral structure. So, if you want to increase the stretch characteristics of a filament yarn, so then if we twist it, the stretch characteristics will increase due to the spiral structure of fiber. So, twist affects the smoothness, bulk and surface feel. If we increase the twist, the yarn bulk will reduce, yarn will be compact. So, depending on our application, we can control the twist level. Twisted yarns are more resistant to abrasion and wear than untwisted yarn, because untwisted yarns will be like if we take the multifilament, untwisted multifilament yarns, if we abrade, so individual filament will be actually affected, but when we twist this multifilament together, this will act as a single unit, and this can be used for knitting, weaving, swing thread and or decorative fabrics. Tightly twisted yarns create dense and compact fabric, and loosely twisted yarns create soft, airy and absorbent fabric. So, that depending on our requirement, we can actually control the twist level. So, advantages are, you can see, twisting of fiber, actually it improves the cohesion and tensile strength, more resistant to abrasion, wear and breaking during handling, provide some stretch and flexibility and improve fabric comfort. Twist level allows control over fabric density, absorbency and drape. Twisting binds loose fibers, minimizing shielding and which minimizes shedding and fuzziness. So, the thing is that, as I have mentioned, that if we apply twist, the fibers are that individual fibers are hold firmly together and it binds the fiber with a greater force, and which minimize the fiber shedding, fiber does not come out. Okay. So, limitations are there: excessive twist makes the yarn stiff, less comfortable for certain applications. So, yarn will be hard and that it is not compressible. So, that will make the fabric uncomfortable, and twist yarn have some stretch, it cannot recover much as specialized elastin yarn. So, that is twist due to increase in twist. So, it will create some stretch, okay, but recovery is not as good as the elastic yarn. Loosely twisted yarn may peel and shed fibers over time. So, like in woolens where loosely twisted yarns are used, that peeling takes place easily, because if you see the peeling behavior. So, this is the, and one fiber is coming out from the structure core. So, here due to rubbing in this is a yarn structure. So, let us see this is yarn in a fabric. Okay. Now, when the fabric surface is rubbed, this is fabric and from one yarn fiber is coming out, this is the fiber. Now, it will form a micro ball at the end. Now, due to repeated rubbing, this ball will be rolled over the fabric surface and this end other end will be pulled gradually and this ball size will increase and it will be a visible nape. So, this the visible peel formation will be, this is a visible peel and this is possible when this will be severe when the twist level is less, because the other end fiber is not being gripped properly. So, the fibers are easily it can come out, but if the twist level is increased, even if there is some fibers are projecting, this rest of the fiber portion will be gripped firmly within the yarn structure. So, this peel formation will not be there. So, high twist can cause fabric skew, curl or distort during weaving and knitting. So, this is due to the snarling tendency of the yarn. Very high twist level are harder to spin and may break during the process. Spinning and twisting requires additional energy and additional different equipment compared to untwisted sliver or roving. Application of twisted yarn, weaving and knitting, that in during for weaving and knitting we need twisted yarn. For sewing threads, ropes and cords, there we cannot use a single filament. So, multi filaments are twisted and then twisted filaments are again twisted, like that we develop cords, decorative textiles, technical and industrial uses, knitting and crochet. Now, we will start the different types of fabrics for protective textiles. So, in protective textiles we use wide range of fabrics like in woven fabric, knitted fabric, non-woven fabric, 3-dimensional fabric. Depending on our application, we use these different types of fabrics. So, what are the fabric structures for protective applications? So, plain woven structure, plain weave, which is tight, durable and abrasion resistance. Next is that twill weave, it is due to flexibility, it is higher tear resistance and used for workwear. So, why the plain weave woven yarn is fabric is highly abrasion resistant? Because plain weave the number of interlacements are high. So, it requires and it is a tight. So, that is why it is tight and So, that for that reason the abrasion resistance is high, and for twill weave it is little bit offset, like there will be higher float. Okay. So, this type of say 1 up 2 down twill weave. Let me draw once again. So, this is the 3 weft yarns are there. These are the weft yarns. Now, this is the type. So, here if you see the this float is longer float. So, due to the longer float, that yarn the during tearing the yarn has got a chance of grouping. So, as the grouping is chances of grouping is more than the plain woven fabric, keeping all other parameters same, the twill weave will have higher tear resistance. Satin weave smooth structure, because the floats are more, sometimes used in ballistic fabric. Knitted structure, if we use the weft knitted structure, it is a stretchable, highly stretchable structure if you want, comfortable, thermal and chemical protective clothing we can produce through the knitted fabrics. Non-woven fabrics for basically barrier protection, disposable PP, medical textiles, filter fabric, we can use non-woven fabric, and non-woven is actually the fabric which is directly manufactured from the fiber. So, there is no need of any spinning separate spinning process. Herringbone, honeycomb, basket weave variants. So, enhance the strength and durability in particularly in woven fabric. And ripstop fabric is also one design, weave design with a reinforced woven structure with excellent tear strength, because with where we need higher tear strength, like in firefighter clothing, military wear or outdoor fabrics. So, tear strength is important, and in those applications ripstop fabrics are used, and laminated and coated fabrics, the combined with the film or coating for chemical, water and heat protection. So, one basic fabric is there, say woven fabric is the, or non-woven fabric, and over the to enhance the performance, like protection performance, the some polymer or some chemical is laminated depending on the application. So, these are the different types of fabrics structures being used for the protective application. We will start with the plain weave. This is the plain weave structure. You can see one up, one down. This is say warp and weft. Now, plain weave is simplest and most fundamental type of woven fabric, with the up and down movement of the threads. by interlacing warp and weft yarns alternatively. One warp yarn, when if it is going downward, next place it will be at the up. Each weft yarn passes over one warp yarn, then under the next one. So, if you see this is the weft yarn, this is going over the warp yarn, then for next warp yarn it will go under the. So, these things will repeat across the fabric. So, normally plain loom is used, maybe hand loom, maybe power loom. It is the simplest one, easy to produce. Select and prepare warp and weft yarn. So, here it is a warp yarn is selected. Then warp yarns are often sized to enhance the strength and reduce the breakage during the weaving. So, these warp yarns are sized here. Size means here is application of some gummy material protection, so that during the weaving action it does not break, because there is a chances of breakage, because there will be many interaction, abrasion will be there and it will be abraded at high strength, high tension. So, that may damage the warp yarn. For that generally we size it at least for the single yarn. Arrange the warp yarn in parallel warp beam, this is the warper's beam. Ensure the correct length and tension for weaving. So, here we have to maintain a certain tension, create a shade in a vertical separation. So, this is the heeled and which creates the separation. For alternate warp yarn. So, one alternate warp yarn will come at the top, move up, and as shown by the blue threads, and then similarly alternate, say even number of threads are moving upward and odd number of threads are moving downward, which is shown by the red color. So, and through that the shuttle will pass, the weft thread will be inserted, maybe through shuttle, maybe by any air jet, by any means, or by projectile, the weft yarn will pass through this opening. And then this, if it is, when it is passing, this is through this the shuttle is passing, and after the insertion of weft, this is the beater actually beats the last thread, weft thread, close to the cloth edge, that is the called fail of the cloth, and wind the woven fabric onto a beam, cloth beam. So, this is typically the system of weaving, and maybe plain weave, this is, and twill weave, the main difference is that the shading, that is the separation of threads. For plain weave it is alternate threads, for twill there will be different types of up and down motion, but this is overall the loom function, and this fabric may undergo the washing, bleaching, dyeing or calendering. Now, what are the characteristics? It has got simplest structure of simplest woven structure, high tensile strength due to maximum interlacing yarn. So, here interlacement is maximum in case of plain weave. resisting to tear, fraying and abrasion. Fabrics maintain its shape as well. Flat and uniform fabric surface. So, because of the this structure, the surface is uniform, can feel stiff if made from coarser or thicker yarn, that is okay due to the yarn bending rigidity. Warp and weft yarns are often of equal size, okay, producing checkboard like look. So, if your warp and weft yarns are made in a different color of equal size, so then one can make the check and different types of design one can make. So, advantages of plain weave: easy to produce, requires less complex machinery and effectively cost is low, productivity is higher. So, tight interlacement of warp and weft gives high tensile strength and abrasion resistance. Dimensional stability will be high because of the high interlacement, distortion is restricted, edges are less likely to unravel compared to some other weave. So, this is because it is a tightly woven, higher interlacement, smooth and flat fabric surface. And the limitations, if we see, stiff and less flexible compared to twill and satin weave. So, this is because of the higher interlacement. Lower aesthetic appeal, because it is a typically it is a very basic weave. So, if we it does not create any special design on the fabric, because it is a monotonous weave, unlike your satin and twill that gives some aesthetic appeal, like satin fabric gives a lustre because of the high float once in one plane, but that does not appear in case of the plain weave. Twill weave gives some certain specialized diagonal line which gives some aesthetic appeal, but here aesthetic appeal is low. Tightly woven plain weave fabric can create any crease easily. Basically, it because here it can be creased easily, less comfortable for heavy fabrics, limited tear resistance in certain yarn, because tear resistance can be increased when there will be movement of thread during the tearing force. As the floats are less and as the number of interlacements are high, so the grouping of thread, chances of grouping of threads are least. Unlike the satin weave where the floats are high and grouping of threads can take place. So, that is why there you will have the higher tears resistance. So, applications there, the wide applications are there. Apparel fabrics are used in shirt, dress, blouses, home textiles, bed sheet, pillow cover, curtains, many applications are there. In protective fabrics, fire retardant clothing. So, we can use the plain weave, industrial uniform, workwear, all those applications plain weaves can be used, and technical and industrial uses. Conveyor belts are mainly made from the plain weave, filter fabrics are of plain weave because of the uniform pore structure, and it does not get distorted easily. Whereas, for other weave, if we can use those weave can get distorted by higher air pressure. Backing for coated fabrics, backing, because of the this higher interlacement, this will give us the coating a better adhesion, better contacts. So, that is why for coated fabrics backing normally plain woven fabrics are used. Printing and embroidery base, for those plain woven fabrics are better, because embroidery for embroidery we need uniform structure. If we try to do embroidery on a structure like satin, then the embroidery due to the thread movement, the embroidery design may get affected. But here in plain weave the patterns are uniform and compact. So, embroidery and printing will be actually will be permanent at that position, at that shape, lining and interfacing. So, these are the different applications of plain weave. Now, our next weave is another important weave, which is twill weave. Twill weave is also used for some protective textiles. Here you can see it actually generates a typical diagonal line. In plain weave it was not available. Now, here you can see this is warp. First warp is when it is a wave, fast wave. For fast wave, this first warp is at the upper side, then following two warps will be at the lower side, and the first wave will go above that, and then next will be here it will be 2 down, 2 up, 2 down, 2 up. In this way it will continue. So, basically here it is called 2 up 2 down twill. Okay. That if it continues we will get a diagonal line. Twill weave is created by in the loom by offsetting the yarn actually movement, because it is characterized by and which will create a diagonal line, okay, or ribs formed by interlacing the warp and weft yarn like plain weave, but in plain weave it is 1 up 1 down, and in twill weave we can have 2 up 1 down, 3 up 1 down, 2 up 2 down, okay. Different combinations we can have, but in plain weave it is 1 up 1 down always, or even 2 up 2 down twill is there. The weft yarn passes over one or more warp yarn and then under 2 or more warp yarn. That is creating a diagonal pattern. Now, production process of twill weave, it is similar to the plain weave. So, we have to select and prepare the warp and weft yarn, arrange the warp yarn in parallel beam with the correct length and tension. The twill pattern requires heeled arrangement to form requires specific headle arrangement to form the diagonal line. Insert the weft yarn through the shade using shuttle, projectile and rapier mechanism. So, this specific heeled arrangement will be there. Then the last yarn is being pushed by the reed, ensuring the fabric is tight and uniform. Then fabric is being wound. And that fabric may undergo washing, bleaching, dyeing or calendering. The characteristics is here distinct diagonal line. So, twill weave is characterized by a distinct diagonal line on the fabric surface formed by the interlacing pattern. So, denim cotton denim is normally very popularly used, and there in the twill design, softer and more pliable than plain weave, giving better drape. So, why twill weave is giving better drape? Because of the float, it has a less interlacement. Longer floats of yarn provide improved strength and durability. Slightly textured surface because of this diagonal line created. The fabric resists crease better than the plain weave. Longer floats make the fabric more flexible, but slightly less stable. So, if we increase the float, the fabric stability will be compromised, but it will be flexible. So, what are the advantages here? Softer and more flexible than plain weave, longer floats provide more tear strength and abrasion strength. Now, I will explain. Suppose this is a plain weave, okay. This is a plain weave, and here we have a twill weave. So, say 2 up 1 down, here the floats are more. So, during rubbing these yarns will move because of the less interlacement, they are free to move, and this will give the this will reduce the relative movement between the abradant and the yarn. On the other hand, for plain weave, as it is tight, so abradant can abrade the yarn with much more severity than the this twill weave. So, abrasion resistance increases, and here in twill weave, due to the loose structure, the yarn may move. There will be during tearing, the yarn movement will be there, which will improve the tear strength, because yarn clustering will take place, grouping will take place, and this diagonal rib, diagonal line gives a textured and stylish look. So, it will give very nice look. Fabric resist creasing better than plain weave, as we have already mentioned earlier, suitable for apparel, home textile and protective fabrics. Ease of finishing. So, if we see the applications, there are large applications are there. So, basically in apparel fabrics, jeans, trousers, jackets, suits, workwear. So, all these places we use the twill weave. For workwear, where the heavy duty clothes are there required. So, we use twill weave for better abrasion resistance. Home textile, upholstery, curtain, bedspread. So, there where it gives aesthetic appeal, and protective fabrics, workwear, work uniform and industrial fabrics. There, due to their higher, relatively higher tear resistance and the abrasion resistance, we use this twill weave in those applications. And tarpaulin, tents, we can use this twill weave. And next weave is satin weave, and that we will discuss in the next class. Till then, thank you.